Let's practice expanding logarithms so we can understand how to apply those properties of logarithms that we've learned. So I've got some examples queued up here. We'll kind of go through them quickly. So in this first example, log base 2 of 5xy, we're going to use the property. I'll write it off to the side here. The property is that whenever you have a logarithm, any base, it doesn't matter, I'm just going to do base 10 here, and you have a product, two things being multiplied on the inside, you can split it into two logs, log A plus log B. And you can check out my other videos to explain why that might be. So here we have 5 times x times y inside that logarithm. So real simple, we just split it into 3 logarithms. Log base 2 of 5 plus log base 2 of x plus log base 2 of y. And that's the answer right there. Easy enough, right? Whenever you have multiplication inside a logarithm, you simply split it into logs that are all being added. Now, you can see on this next example, we've got some subtraction going, or I'm sorry, we've got some division going on. Well, as you can imagine, that's going to be subtraction of logarithms. So let's write the rule over here. When you have log of a divided by b, it doesn't matter the base, by the way, you end up getting log a minus or subtract log b. Now, I'll have a real good way to think about this. In my opinion, anything in the base simply becomes a negative log. It just makes things easier, as you'll see as we go through this video. But anything that's in the base inside a logarithm can be made negative as a separate logarithm. So you see on the top here, we have a 6 and we have an x. Those are both on the top, so they are going to be positive. So this will be log base 3 of 6 plus, again, because these are both on the top, log base 3 of x. And then, because this y is on the bottom, we're going to write a separate log, but it's going to be negative, minus or subtract log base 3 of y. And you can test this with numbers, like for example, go to your calculator and like maybe 7/3. Type that in the calculator and get the decimal. I don't have my calculator handy with me right now, but you can do that, right? Type it in, log 7/3, and then check, is it the same thing as log 7 minus log 3? And lo and behold, it will be, trust me, because these are the properties, they are the truths. So let's go to this next one. Log of x minus 1 all over 4 times y. Now, we have multiplication in the bottom, but don't worry about that, or don't stress about that. If you just keep my way of thinking in mind, it helps. Anything in the bottom, a 4 and a y, are going to be negative when we write this out. Now, what do we have in the top? How many factors do we have in the top? We only have one factor. So we can only split that into one logarithm, and it's going to have x minus 1 on the inside. You can't split that into log x minus log 1. It doesn't work that way. Okay, that's not one of the properties. So we have to play by the rules here. So we have log x minus 1, and then we have log 4. Now again, I know that it is multiplication. I've helped a lot of students with this over the years. I know this is multiplication, so you're thinking, but I thought you said up here, when you multiply, you have to have plus, right? Well, we're going to be subtracting both of these things, which if you think about the distributive property, we distribute a minus sign on both of those, they both become negative. So that's why it's going to be minus log y as well. All right, so hopefully that example was helpful for you in a couple different ways. I threw a couple little curveballs in here and there just to give you a look at some of the common mistakes, things that might trip you up. Okay, so we have an exponent this time. So there's another property of logs. The third one, pretty much the final property, is that whenever you have an exponent, a to the n, inside a log, that can be thrown out front of the logarithm. So we end up with log a then. So this exponent gets thrown out front and becomes a coefficient. It becomes multiplication, because after all, a power of a power, you multiply when you're dealing with properties of powers. All right, so I see two things here. I see a log 3 plus a log of x to the fourth, right? We've got two things being multiplied in here, 3 and x to the fourth. That power of 4 is not on the 3, it's only on the x. Now what can we do with this exponent again? We can rewrite it out front. So I'm just going to go ahead and erase the 4 and put a nice big 4 in the front as a coefficient. There we go. That's the answer. That's how you do this. Any exponent, you just put it out front of the logarithm as a coefficient. All right, so we've got quite a bit going on. I would suggest you pause the video and just try this problem on your own. Let's see. And by the way, this is the natural log. ln is the natural log. That means it's base e. All right, so how many different logarithms are we going to need? We're going to need 4 logarithms, because I see 4 bases. I see a y, I see a 5, I see a 2, and I see an x. So let's split these into their logarithms first of all. X to the third, and then the ones on the bottom will be negative, right? We talked about that. Minus y squared. At this point, you start throwing the exponents out front. So we get natural log of 2 plus 3 natural log of x minus natural log of 5, no exponent there, minus 2 natural log of y. So once you do a few of these, it really becomes pretty straightforward. You just got to keep those 3 properties straight in your mind, and you'll be in good shape. All right, I just have a few more examples here lined up, again, with a few curveballs. So what's different about this problem? All right, I put a 2 way on the outside, didn't I? That's okay. We've got 2 options for us. You could either put this out front and then work the problem this way, and I think I will actually work it both ways for you. All over y squared z. And then, you see how I put these parentheses? So then you work this problem, and at the end you can distribute the 2. That'd be one way to do it. Or, why not just use your properties of exponents first? Because you're allowed to do that if you want, because it's one of the legal moves you can make here in algebra. We have 4 squared, which is 16, x to the 6th, because power of power you multiply, all over y to the 4th, z to the 2nd. All right, so all I did was I took this exponent, and all of the exponents in this problem get multiplied by 2. All right, so then this, of course, splits up into, this would be log, I'll just write log 16 rather than 4 squared, plus 6 log x minus 4 log y minus 2 log z. Because that z was in the denominator, I had to make that guy negative, right? Okay. Now over here, if you did the same thing, you would end up getting 2 times the quantity, and you would get log 4 plus 3 log x minus 2 log y minus log z. And then do you see, if you multiply all the coefficients, just the coefficients by 2, you'll get this blue answer back. So you could do it either way, whatever works for you, whatever seems easiest to you, go for it, use it. All right, I think this is the last problem, and I wanted to throw a couple binomials at you again. There was one example earlier. Let me scroll back here, I'll show it to you. Remember this example here where I said, you know what? This is a binomial, and it can't be split up. There is no rule about a plus b inside a logarithm or a minus b. There is no rule. because there's really literally nothing you can do with that. So all we can do with this problem, folks, is split it into log of x squared plus 4 minus log of y to the third minus 5. Now you're thinking, now wait, Mr. White, wait. I see exponents. Can't we throw those out front? No, because this is a single factor. It's called a binomial. The exponent on it is just a 1. This exponent is only on this term. That's called a term. So we can't like pick and choose and take that exponent and throw it out front of the entire thing. So this entire thing has an exponent of 1. This entire thing has an exponent of 1. So no, this 3 cannot be thrown out front. That's the answer. Okay, so I wanted to show you that little curveball there that maybe your teacher, like Mr. White or others, might throw at you during a quiz. All right, well, hopefully this was helpful in explaining how to expand logarithms. I'll make another video on how to condense them. So, all right, until next time, good luck.